Hello grade 11s and welcome to question number 5. This is a question on electric circuits. Now before we take a look at the question, I'd like to remind you of the formulae on your formula sheet. Firstly, we have a formula that we can use to calculate current. Remember that current is measured in amperes and it is the rate of flow of charge, where charge is measured in coulomb and time is measured in seconds. We can calculate resistance by making use of Ohm's law. Resistance is measured in ohms. Voltage or potential difference is measured in volts, and as mentioned, current is measured in amperes. This formula is the formula that we can use to calculate the effective resistance in a parallel connection. The one on the right hand side we use to calculate the total resistance in series. Then we have 4 different formulae that we can use to calculate the energy dissipated or energy used up by a device or emitted by a device. And remember, another way of describing energy is work. Work and energy are both measured in joules. Then we have power. Power is the rate at which work is done or rate at which energy is dissipated, and it is measured in watts. So don't confuse watts, which is given the symbol W, with the W that we use as the symbol for work or energy. So let's now read question number 5.1. It says the circuit below shows the 8-volt battery with negligible internal resistance and negligible resistance of the connecting wires. When switch S is closed, the reading on the ammeter A is 2,2 amperes, while the reading on voltmeter 2 is 4,4 volts. So let's go ahead and close the switch. Then we can see that all of these values mentioned are on the diagram, which is very fortunate. We don't have to fill it in ourselves. Before we go on with the problem, let's try and analyze what's going on in the circuit. Is it a series circuit? Is it a parallel circuit? Or is it a combined circuit? We know that the long side is the positive side and the short end is the negative end. And conventional current moves from the positive to the negative terminal of the battery. I suggest that you use a highlighter in order to do this, which I'm going to do, which is basically to see how current flows in the circuit. Firstly, we see that it exits the positive terminal, flows down, and gets to this point. At this point, the current is going to split. Some of the current is going to go this way, and some of it is going to go that way. Then it meets up again and it's all going to flow through the 2 ohm resistor all the way around through the ammeter to the other end of the battery. So notice that the 2 ohm resistor is connected in series with the battery because the same current that flows through the battery flows through the 2 ohm resistor. The battery and the 2 ohm resistor are in series with the ammeter. So the ammeter measures the current through the battery and the 2 ohm resistor. But the 3 ohm resistor is connected in parallel to resistor R. And therefore the current divides when it gets to this junction over here as it splits between the 3 ohm the 3 ohm resistor and resistor R. We can say that these 2 resistors are connected as a whole in series with this resistor, and therefore we know that the 8 volt is going to be divided between the parallel connection and the 2 ohm resistor because potential difference is divided in series. So we see potential difference is divided, and at this point the current is going to be divided. It will come back together over here. But current divides in parallel while potential difference divides in series. A big mistake that a lot of my learners tend to make is to assume that the potential difference on the battery is equal to that measured across the parallel connection. But that is not the case when we have a combined circuit. So now we go on to question 5.1.1, which says, state Ohm's law in words. In words, we say that Ohm's law states that the potential difference across a conductor is directly proportional to the current in the conductor specifically at a constant temperature. We normally award 1 mark for the first part and 1 mark for the control. And remember, we can see this in the actual formula. The Ohm's law equation is R equals V over I, and if we manipulate this, we get V equals I multiplied by R. So naturally, as the current increases, the potential difference is going to increase as well, and they are therefore directly proportional. But please do not forget your constant, or you're not going to get your 2 marks. Question 5.2.1 says, calculate the reading on voltmeter V1. V1 is measuring the potential difference across the parallel connection. And remember, we said that potential difference is going to be divided between the parallel connection and the 2 ohm resistor. So therefore, V1 is going to equal to the total potential difference minus the potential difference measured by V2. We have 8 minus 4,4, and that gives us a final answer of 3,6 volts. That is the potential difference measured across or by V1. And we can go and indicate that on the diagram. We're going to get 1 mark for the workings and 1 mark for the final answer, provided that we include the correct unit. Now they say, calculate the value of the resistor. Here we are referring to resistor R. Resistor R is connected in parallel with the 3 ohm resistor. It is connected in parallel to the voltmeter called V1. So we know that potential difference is constant in parallel, and therefore we can write down that the potential difference measured across resistor R is also going to equal to 3,6 volts. So if we would like to know the potential difference, not the potential difference, but the resistance of resistor R, then we need just one extra bit of information. And that would be the current flowing through resistor R. But we can't find that out by making use of resistor R itself. Instead, what we can do is we can remember that this potential difference is not only measured across resistor R, but across the 3 ohm resistor as well. So how about we start off by determining the current that is flowing through the 3 ohm resistor. Current is equal to potential difference divided by resistance. So I is equal to V divided by R. You're welcome to write down this formula in its original form, so you do not need to manipulate the formula. So we have 3,6 divided by 3. And when we plug this into our calculators, we obtain an answer of 1,2 amperes. So now we know that the current that flows through the 3 ohm resistor is equal to 1,2 amperes. 2,2 amperes comes over here or flows around the circuit and is going to split up at this point. If 1,2 amperes goes this way, then to determine what goes or flows through resistor R, we're simply going to say, therefore, the current through resistor R is going to equal to the total current minus the current through the 3 ohm resistor. That is going to equal to 2,2 minus 1,2, which means the current is equal to 1 ampere. So now we know the potential difference across resistor R, and we know the current that flows through resistor R. We therefore say R is equal to V divided by I. That is equal to 3,6 divided by 1. And we therefore determine that the resistance of that resistor is equal to 3,6 ohms. Now this question is out of 5 marks, so marks will be awarded as follows. You're going to obtain 1 mark for your substitution when calculating the current through the 3 ohm resistor. 1 mark for your method of calculating the current through resistor R. 1 mark for the Ohm's law equation. We're going to take this away, okay, because that is not a mark. I just used that while we were performing the calculation. Okay, and so far we're on 3 marks. 1 mark for your substitution into the Ohm's law formula, and 1 mark for your final answer, the value of resistor R, giving us a total of 5 marks. Now we move on to question C, which says we need to calculate the energy dissipated by the 2 ohm resistor within 5 seconds. We start off by remembering that the symbol for energy is W. Okay, so power is measured in watts, but energy is given the symbol W. We now need to determine what we know about the 2 ohm resistor. Firstly, we know its resistance is equal to 2 ohms. Secondly, we know that the current that flows through it is 2,2 amperes. Thirdly, we know that we are looking for the energy dissipated in 5 seconds. So the time is going to be 5 seconds. We have 4 formulae to choose from, but the one that involves current, resistance, and time is this third one over here. So to answer the question, we're going to start off by writing down the formula. W equals I squared R, change in time. We plug into this formula the values, which is going to be 2,2 squared, don't forget the square, multiplied by 2 multiplied by 5. In the end, we obtain a final answer of 48,4, and this is energy, so it's measured in joules. The question is out of 3 marks, so you're going to obtain 1 mark for your formula, 1 mark for your substitution, and 1 mark for your final answer. Let's now look at the last question in question 5.1. Question 5.2 we're going to handle in the video that follows this one. 5.1.3 says, will the ammeter reading increase, decrease, or remain the same if the 3 ohm resistor is removed? Give a reason for the answer. So firstly, let's determine where the 3 ohm resistor is. The 3 ohm resistor is part of the parallel connection. So I'm going to erase as much as I can so that you can understand this. The switch, of course, is closed. When we remove this resistor, what is going to happen is we are removing a resistor from the parallel circuit. What then happens if you remove a resistor that was connected in parallel, right? If you do that, then what is going to happen is that the total resistance is going to increase. When you add a resistor in parallel, the resistance decreases. When you remove a resistor in parallel, the resistance increases. It's a weird phenomenon, but it's true. Now, if total resistance increases, remember resistance is the opposition to the flow of current. So if resistance increases, then of course we know that current, or the total current, which is measured by the ammeter, is going to decrease. So what is basically happening is, instead of the current splitting, all of the current is now going to flow through this part of the circuit as follows. So the correct answer to this question is going to be the current is going to decrease. For writing that down, you're going to get 1 mark. And the reason is because when we remove the 3 ohm resistor, the total resistance in the circuit is going to increase. For writing that down in words, not in simple form as I have, you're going to get 1 mark. Now remember, question 5.2 we're going to answer in the next video, so please be sure to join me there.